Hello, and in this presentation, we're going to start talking about arrays. Arrays are data structures, and data structures are a way of grouping your data together so that you can easily manage and maintain and access that data at the same time. You can think of them as collections of related data. In fact, a lot of languages have the concept of a collection, and a collection is just a way to group data together and share some common functionality. Some common collections in various programming languages include things like arrays, lists, and maps. Arrays are perhaps the simplest data structure. In some languages, arrays tend to be fixed length. And what that means is that once you create an array of a specific number of elements, you can never change that number of elements. You can never have less or more. Now, there are ways to get around that by creating new arrays and using some static methods in different languages to create new arrays based upon previous arrays. But in a nutshell, arrays that are fixed length cannot have the number of elements change. Now, the data within the array can certainly change, but the number of elements cannot change. So you can think of arrays as a long box with compartments. If you've ever seen those pill boxes that have different compartments, one for each day, you can think of the giant box as the array and the individual days as different elements. Now, when I say element, I mean the data that exists in one part of the array. The whole point of the array is to group things together that are similar. So in the case of the pill box, we could have a different variable for each pill, an aspirin for Monday, an aspirin for Tuesday, an aspirin for Wednesday. But what tends to be more useful is having a single data array called pills. And then 0 representing Sunday, you could have, aspirin, Tylenol, whatever. And that way you can access all and store all of the data together. So in some pseudocode, we've got an array of pills, and like I said, you've got Sunday's pills, Monday's pills, Tuesday pills. The thing to note is that when you're talking about arrays, in most programming languages, arrays begin at 0. So it's the 0th index. So if I was going to get the pills for Sunday, which is in the first element, it would be array of pills 0. I know that can be a little tricky if you're not used to that. There are some notable exceptions. For example, Visual Basic tends to use 1 as the first element, which may make logical sense, but when you start understanding things like memory allocation and offsets, the use of the number 0 is more logical. So under the hood, an array actually points to a block of memory that contains the individual elements. That's why in many languages you can't resize the array, because when you initialize the array in memory, it creates all of the elements in a contiguous block of memory. Now, in most modern programming languages, that's not something you really need to be considered with. They're going to abstract that away. They may not be contiguous. They may have linked lists and pointers, but historically, that's how arrays were managed under the hood. So you would get into situations where you need to keep it all together for, pointer arithmetic. And that's why historically a lot of programming languages, especially static compiled languages, would not allow you to change the number of elements. So given that memory structure, I hope the 0th index makes a little more sense, because what you're talking about is start at the very beginning of the memory allocation. And you can start doing things with finding out the memory offset, which, again, this is more for languages like C and C++, where you can use the memory offset to do some pointer arithmetic. In most modern languages, you don't necessarily have to do that, but again, that's the background, and that's the reason that arrays start at element 0. So why would you want to use arrays? Well, like I said earlier, you want to combine your data together. If it's easier to manage, if it's easier to maintain, if it's easier to logic about, then it usually makes a lot more sense to keep it together. And arrays allow you to do that to some extent. So let's imagine we have student grades in a specific class. Now, we're just talking about one exam or one assignment. If I had, say, 3 students, I could create 3 separate data variables. I could have student 0 grade, student 1 grade, student 2 grade, and set those to the numbers. But you can see that that's going to start becoming very difficult to maintain. What if I need to get the average of all the grades? Well, I could write a very basic pseudo function where I add all the values together and then divide by 3, but what happens if I need to add another student? Well, then I need to create the new data variable. I need to make sure I add the data variable into the total grade function, and I need to remember to increment that divisor by 3. Obviously, if I have to add 10 students, 100 students, that's going to become very unmanageable and is going to open up our code to a lot of bugs. It's going to become very brittle. So in that regard, we'd want to use an array. So let's imagine that I have the same 3 students, and again, I'm only concerned with one specific assignment, so I'll just call it student grades. I'll create a new array and set the values to 98, 88, and 95. Now I can operate on the array. Adding a student is as easy as adding the number to the end. Now I put an asterisk there because remember, if you initialize an array in some languages with only 3 elements, you can't just add it without recompiling. Again, depends on the language, and we'll see some more examples of that when we start talking about individual languages. But just keep that in mind that sometimes it's not quote-unquote as simple as just adding another variable to the end. So let's imagine we wanted to get the average. Now this might look like more code. In reality it is, but it's far more flexible. All right, so using the pseudocode again, I've got a total grade, just a placeholder of 0, and I'm setting the index to 0. And what this for loop is going to do is it's going to loop over each element of the array. So we're going to start at the 0th element, and while that index is less than the actual number of elements in the array, so the length property, we're going to loop and then increment the index operator. So when we're in the loop, we set the total grade equal to whatever the total grade previously was, plus the current element at the student grades index. And then to get the average, all I need to do is grab that total grade and divide it by the length of the array. Now, if you don't understand all of this together, don't worry, it'll make a lot more sense when we start talking about individual specific languages and we show some real examples. But the key here is that as long as my data structure doesn't change in format, for example, as long as it's always an array of integers, it doesn't matter how many are in there. This code is going to be flexible enough that it will not need to change. Which means if I need to add a student, I don't have to change the average grade logic. I don't have to change any of the lookup logic. This is flexible enough because I'm using the length property. I'm using the array on its own as its own explicit data variable, so I don't need to necessarily worry about changing any of the logic. So depending on the language, looping can be accomplished differently. The one that I just showed you is this first one. It's the for counter condition operation. Another common paradigm is the for element in array. And essentially what that's going to do is it's going to loop over every element in the array and is going to set that element variable to whatever the current element is. And if you don't necessarily care about the specific index that you're in, so for example, you don't care if you're on the first, third, 100th element, you just care what that data is, then this can be a lot easier to maintain. And in some languages, you don't have a for structure, so you'll just use a while loop. That's not as common. Typically, you will use a for loop. So the other thing I want to talk about is that arrays can contain other arrays. And this is known as a multidimensional array. You can think of it as a grid. So a two-dimensional array, which is just an array of arrays, you can think of it like a spreadsheet. If you open up Excel or Google Sheets, what you're going to notice is that you have a row, and then you have a row, and then you have a row. And each row has its own set of columns. Well, that's kind of what a two-dimensional, multi-dimensional array looks like. You have an array at each element of the initial array. So it's an array of arrays. Now, one thing I will caution is that it can become very difficult when you start talking about arrays of arrays of arrays of arrays. If you have an 8-dimension array, it can be very difficult to understand where your data is. There's no real technical reason why you shouldn't do that or why you can't do that. It's more of a logical understanding reason. Typically, if you get into a situation like that and you're not doing something with some advanced mathematics, you probably want to examine your code and your approach to make sure that there's no other way to handle that data. So there are pitfalls to arrays. They're not a panacea. In many languages, arrays can only hold one type of data. So for example, you can only have an array of numbers or an array of strings or an array of students. In many languages, you can't change their sizes. We've talked about that previously. And in some languages, arrays can be difficult to reason, especially if there's a lot of different initialization logic or the length isn't necessarily clear. There's also the pitfall of a off by one error. And in that regard, you're either trying to access one element beyond the maximum number of that array, which will tend to throw an out-of-bounds exception or some sort of similar error and crash your program. Or if you're trying to do math on that array, if you don't consider the final element and you have your condition a little off, you could get some incorrect results. If you have a loop and you're changing the array internal to that loop, or you're resizing, or you're doing a lot of work on that loop, you can start running into performance issues. Now, for smaller arrays, that's not a really big deal, but when you're talking about arrays of database rows and you're adding data and you're manipulating that data and you're doing that within a large loop, you could definitely start running into some logic or some performance issues. And then in some languages, such as JavaScript, arrays are essentially just glorified objects. So the context can be confusing depending on how you're accessing the data within that array. In future lessons, we're going to talk about some different workarounds, such as the collections and generics. But arrays are a good first step towards better data management and allocation. So to summarize, arrays group similar data together. They expose functionality on a collection of data so that you can manipulate the data as a whole rather than trying to group ahead the individual elements separately. In their most primitive sense, they have limitations and must be recognized, but if you understand those limitations, they can be very powerful tools.